So the login page, which is sort of the first point that a user is going to be interacting with the website, it uses middleware routes throughout different pages of the website to redirect to the login page if the user doesn't have a session cookie. So that means we can sort of enforce that authentication if we want on certain pages. So if I put in an existing user, let's say I try to sign up as Ethan, and then like what about.com, and then just add a like password ABC, maybe add like an image. It should not allow me to use the username because the username's already in the database. So maybe I'll try using a different username. So Ethan test maybe, and then like Ethan test Gmail, and then I'll use ABC as my password. So I'll try signing up again. That should allow me to create a new user. So now I've been signed in, I've created a new account. So if we check the database, what it does is whenever it's checking in the actual login route, it uses sort of the parameterized query for checking the database, making sure there's no SQL injection or any of that funny stuff. But we can see that Ethan test has been made with the password, which has been sort of hashed using the bcrypt with Salt, so that if there's any duplicate sort of passwords that are used, it will be still unique. So the friends, now that I've logged in, I can access it. The friends page uses sort of mainly a singular modular route that it uses for most of the things, which is search users. You can see that I've got no friends at the moment because I haven't actually, I just created this account, but it loads it in like a certain X amount of people, and then I'm sort of using it as modular, so to get the initial people, I just don't have a search string, so it's just nothing and it loads in anybody. So if I wanted to add, you can see like Ethan, maybe I want to add as a friend, I can add in Ethan, and then Fred, and then maybe like QWERTY or PImage as a friend, and then get friends is used at the start of reloading a page, and then it'll fetch all of the friends that I currently have. So it uses the blob storage image that's saved in sort of the long blob format. It processes that on the database side before actually sending it down to the HTML and JavaScript and all that, so that it can easily be displayed, rendered on the page quickly. If I was to search users, I use debouncing, so like Jerry, or this would be limited to people in the database. But if I search for Jerry here, you can see that Jerry's in the database, and it's also got debouncing. So if I search for anybody with like ER, you'll have ER here, and the debouncing just makes it so that it's not sending out a ton of API calls, but it's also fairly quick. So I can add them as friends, and then I've also got a popular filter, which the actual database or the client side sends and ranks the people on the client side. So that means that I can automatically just rank the people in terms of popularity, or like in nodes however many friends they have, and then so you can find the most popular people and then add them as friends. So yeah, that's pretty much all mine.
The database integration part, which is the list feature in Drinkly. When building a database in Drinkly, one of the key challenges was how to associate the correct data with the correct user, and this was solved using server-side sessions, which stored the current user ID. When I go to lists, it pulls up the drinks that I already have according to my user ID when I logged in. And you create a new list by creating that. You give it a name, you enter a random description, and you select one of these 6 icons. It pulls up this new window where you can query different drinks using the CocktailDB API. So for example, if I select I select this drink, or Bloody Mary, for example, it saves up in the selected drinks feature, and when I click save list, it saves it to the database. And so the new list testing shows up with all the selected drinks inside of it under list.js, which is the backend for my list feature that I was demonstrating earlier. So as you can see here, I always use parameterized statements and never directly interpolate from the user input into raw SQL strings. Hence, I avoid SQL injection. Another feature of my database was that, for example, in the save full list feature, I used transactions. So that's meant that if anything's failed during the database saving process, I would roll back the entire operation. Hence, my database would always be consistent. Another feature that helped improve the performance of my database is using batch insertions. So as you can see here, if a user selected many drinks, I saved them in an entire array, and I inserted them into the database using a single statement. And this is much more efficient than running multiple insert statements multiple times. Atomic values such as email or username, which is indivisible, and every single table having primary keys. The second normal form is satisfied by having no partial dependencies in tables with composite keys, such as the drink ingredients table, which uses drink API ID and ingredient ID as the composite key. The attribute measure depends on both, not just one, satisfying the 2NF property. The third normal form is having no transitive dependencies, such as in the users table. The user's email and profile image depend directly on ID and not username, or some derived field. Other optimizations in our database is the feature of on-delete cascade. In the drinks review table, whenever the user deletes their account, all subsequent comments are deleted, maintaining referential integrity. All tables are more broken up into small rows, such as followers, users, ingredients, drinks, and this separation allows for more modular and optimized querying. Other optimizations in our database include query optimizations by using indexing. In the user list table, for example, we use the unique constraint, and this allows for faster lookups. In the user list drinks, for example, the primary key uses both the list ID and drink API ID, which allows for faster filtering.
Hi, my name is Aidan, and I'll be discussing the CSS styling used throughout, as well as the HTML format that we have used. So to begin with, I was also responsible for implementing the optional feature, which is the dark mode. So all you have to do is just click this button over here, and it creates the dark mode website. So we've got all this applies the dark mode styling throughout. So the dark mode styling is in the JS. We've got the JS script that toggles the dark mode, and then we've got the style.css, we've got the root, which is the default color, and we've got dark as well, which is all the dark mode features there. So basically the way I've gone about style.css to make it as modular and as efficient as possible to optimize everything, I've got a style.css boilerplate. So this is the file here, which has all of the global styles that are used throughout to make it easy to use globally. We've got a search.css, login.css, list page, friends, drink page, and create list CSS. So these are all responsible for their own things. We've got the CSS here for the styling, which is for the drinks page, which is part of this thing here. So if you were to search for drinks, and if you want to click on a drink here, you've got specific styling just for this page here. It looks different, just to make it look, just to make everything stand out while also being modular, so it's easy to use throughout. We've got the create list here, which looks different. So basically the method that I've gone through is to make everything as distinct as possible while also making it easy to use throughout. So with the HTMLs, they're easy to use. So everything on the top is basically the same thing. We've got the dark mode here, the script. We've got the links here for the style sheets, and the same font as well, which we've used Railway for that. The headers, so we've got the header here. This is consistent throughout the entire website to make it look, it's the same throughout, make it just look normal. We've got the, I should say the login as well, so we've got the login styling as well. Yeah, so basically the code that I've created here for the HTML and the CSS mostly just follows a format, so we've got the same format here for each HTML. Each HTML has their own distinct file, but each HTML is distinct, but also follows the same format, just to make it easy for users, for us to develop, and also easy for the users to interact with the website itself. So when you got home, you got the search. This search bar is the same for the friends one as well.
Hi, my name is Ziku, and I'll be walking through the drink search and review functionality of our Drinkly app. So here on the search bar, when we type in the name of a drink, like margarita, we press enter with the search button here, our app will send a request to the CocktailDB API. The name is a query through a backend router /search, right here. So this route uses fetch to retrieve matching drinks from the external API and sends all the drinks as results. And this is then displayed on the front end for the user to choose. So now when I click on a specific drink, it will take me to its individual page. This triggers a request to another router, which uses the drink ID to fetch detailed information from the same external API about the chosen drink. So the data returned includes the name, image, ingredients, and preparation, which is then rendered into a detailed page. So now onto the review section. This is where we integrate the external API with our custom database. So when a user writes and submits a review, a post request is sent to a router /add review. Let me just demonstrate. Right here. So basically on the back end, we first check if this drink is already in our local drinks table using its API ID here. And if it's not, we fetch the drinks info from the external API and insert it into our own database. So this allows the review to be linked to the specific drink. Then the review itself is saved in the local drink review table in our custom database. The review is then linked to both the drink's API ID as well as the logged in user's ID from the session. So this just lets us take basic drink data from the external API and just build on it with user-generated reviews. So by storing the drink locally, we can link it to reviews and user accounts, making the experience more interactive and just more tailored to our app. So Vue plays a big role in optimizing performance. When actions like toggling tabs or like submitting a review happens, Vue updates only the parts of the page that change, so without a full reload. So just using its reactivity system, the interface stays responsive and efficient, dynamically reflecting updates as they happen. So this reduces overhead, which creates a smooth user experience.